And let's say that this is the library. And our users are on, we want them to be on the 192.168.1. We'll put them on the 11 network, right? 0/24. And if y'all remember from your essentials class, that slash 24 means that we can go all the way up to 255 or 254 on the addresses. So now we have this allocated for them, but that doesn't necessarily mean that we have 200 PCs that's going to go in the library. We just know that we're going to give them a logical address of 168.11. Now, in order to do that, we're going to need a router over here. This is a symbol for a router. So what I'll do is I'm going to group this. This is a router. And on that router, we need a switch. Shrink this down a little bit. Put this over here. So this switch and that router is all here. Now, they're not connected to the, I don't want you to look at the library as being the main thing. So you know what I'm gonna do? I'm gonna put this off to the side. And what I'll do also is I'll take it down and make it kind of blurry. So the main thing will be the router. Let's get a cloud in here. And this cloud, Jesus. Can we change the color on that? Forget that cloud. Bomb. This is the internet. 9 times out of 10, whenever you see a cloud on a network diagram, that means this is the internet provider. This is how you go out to the internet. Now I'm going to take these wires here and I'm going to connect it to the internet if I can. Take that one piece, connect it to the router, duplicate that. And then I'm going to connect that. I can straighten it up. Bring that forward. So we can see from the internet to our router at a layer 3 to our switch. Our switches are going to connect to each one of our endpoints here at the .11 domain or network ID. So remember what I said, we had like maybe 48 ports on that switch. So maybe we put more switches here if we need to, right, as we grow. But that's pretty much setting things up in the library. Now we can also put some printers over there, right? Of course. But what do we want to put that on the user level? Do we want that to have the same network ID? Or do we want to put it at a networking level? So maybe you have different layers of that library. Maybe someone else is having an office in there. Maybe there's staff and faculty in there that has offices. Maybe they need to print to that printer as well. So we don't necessarily want to put them on the student level if this is dedicated to the students. Maybe we want to put them on a different network. So what I'm going to do is I'm going to set it up here, and I'm going to take this, duplicate it, bring it down, get me a IP address. And since we're on the 11 network already with the students, we're going to put our appliances on a .12, right? We're going to say a 24 as well. So now, any printers that I bring in, let's just say if I bring in a scanner, a fax machine, things that are similar to these endpoint devices, instead of they being on a logical ID with the the computers, I have them on there as other output devices on the .12 network is what we'll say. Okay. Now, not only that, so I got this server right here. This server has the records for, no, I don't want to say the records, but let's say it has the library's website on it. So I need to connect that to the router as well. Connect that to the router as well, and then I'm going to give that a different IP address of, I'm just going up the scale, 13. Y'all following me? Thumbs up in the chat if that is okay. All right. Now the last symbol that you see here is the SQL server. Now, CompTIA is not going to tell you that this is a SQL server, but I know sometimes the SQL server icon is just the same as a database icon or a server icon. Sometimes they all use the cylinder piece, but in this case, this is the SQL icon. So remember from my last class, we said SQL is probably going to deal with some type of database. And so let's say this is the database for all the books that are recorded within that library. So bear with me. I need me another network cable. Throw that up there like that. Jesus. Trying not to get these arrows mixed there. Okay. So, oh yeah, and I need what? I need another IP network ID for that. So since we got 13 going, now we can have 14. Now, the lovely thing about that is, like I said before, if the students get a virus here, if the students are affected here, then I can contain it in the network ID of .11. I don't have to worry about it spreading over here. It's not going to go that far. It's not being contained. It's not going to be able to jump and then route itself over here. Same thing if it was to come into the ports. Let's say we left the ports open on our printer, then we're not going to really have to worry about it jumping over to our servers. Yes, sir.
Is this because they are not on the same local network?
Say that one more time.
Is this because they are not on the same local network?
Yes. By me You see how we got those first three octets are the same? Well, the first two, 192, 168, but then we change each one of them up. These are called subnets 14, 12, 13, and 11. Now they all are, those subnets are able to communicate with the router, but they're not able to communicate with each other. Not like that. So, okay, they have to communicate with each other because the students have to print, right? And they have to get to that server. They have to get to the SQL server as well. But what I'm saying is that they're not going to compete. They're not going to have the same network address to allow for lateral movement within the same network. The easiest way I could show you is this. My virtual machine shut down. I'm gonna spin this back up, and while that's doing this thing, I'll wait. I'll show you that. But to answer your question, they're segmented. They're segmented off. Think of it like their own silos. This is its own network. So I can add plenty of more servers here just on this network. Okay. I can add a couple of more printers. Now they all get different. They get the same network ID, the 192, the 168, the 12, but then the second one right here will get an IP address that looks like this. Okay. It has the same network ID, which is the first three octets. But that last octet is particular to this particular new printer. Okay. That makes sense?
Yeah, it does.
Okay. So, and the same thing goes for these new servers. Now, no, they don't get the dot zero. I don't want to confuse you with that. The dot zero is just kind of setting a precedence of this is the naming scheme that we're going to use for this network. But it will start off with dot one, dot two, go all the way down to 254, and then that'll be all that we can add in within that network. That's that VLAN or that sub network, if you want to call it that. Now, let me get that off. Shrink this a little bit. Now, same thing when it comes to what did I say? This was the admin building. So let's go a little bit lighter. Over here. We'll put it on this side. Remember, this is a switch. And then we're going to put our SQL. We could put it wherever, right? So just because I put it up here doesn't, and that's another thing about the logical piece of it. Just because I put it near the cloud doesn't mean that it comes off the cloud, hits the SQL server first, then the router. It's going to come from the cloud, the internet, to the router. The router is going to pretty much direct traffic wherever it needs to go. Okay. Now another thing. Well, let me set this second network up. So we got admin over here. This is the admin building. Router, switch. Let's throw a end user on here. So this is faculty and staff. And there, hold on, let's put our servers out here. Our printer right there. Well, I'll leave it down here, and I'll leave our SQL up here. Now, you see how I rearranged it differently, right? I could have kept it just like this and just duplicated it over here. But what I'm trying to get you to see is that since it's logical, it doesn't matter where we put it at. We all know that it's going to start and end here. Because why? This is going to go all the way out to the cloud. Let me skip that SQL like that. That's going to go out to the cloud. Okay. Then we can say this joker goes here to the printer. Duplicate that network. This goes down to the, and bring this switch forward. This network cable goes from the network, from the router to the switch to the endpoint. I know you just see me just kind of go through all the way through it, but that's where it goes. Now let me bring this to the front. And then we got two more. Duplicate. Got that SQL server. Goes out to the router as well. And why do we want everything to the router? So everything can be connected and have communications. So now faculty and staff is talking to the internet, and they're talking to each other. Do y'all want me to put IP addresses on, do the network IDs for these? Give me a thumbs up, or if not, I'll just go to the next point I'm trying to make. All right, so I'm gonna put the network IDs on these. So I'm gonna kind of go in the same scheme, but since it's a whole total different building, right? So let's go to the 20s. So I'm gonna put 20 over here for the, and I'm gonna start at the endpoint. Duplicate that. I'm gonna do, somebody put in the chat what's gonna be next for this network ID. If I got 20, if I'm just going up with one, it's gonna be 21, right? Thumbs up. Cool, appreciate it. Duplicate that. Now my endpoints on my printers is going to be 22. And then I'm going to go up to my SQL servers, and I'm going to have 23. Appreciate it. Now, here's the question. My switch still ain't came up. Okay. We need to give the router a network ID as well. Let me put my virus over here. The router needs to have a network ID. Now, normally, what a network ID for a router looks like is going to look like 168.1. And we'll still leave it with a /24 just in case we want to have redundancy in our routers. Remember that? And so where you talking, Power 5 schools, University of Alabama, right? They probably have their routers are probably starting off at the network ID of 192.168.1. And then they have the growth to go and put hundreds of routers in at different buildings. So since that's one, I have a router over here that I need to have on a different network as well. If it'll ever let me do it, okay. I'm gonna put this on a different route as well. Could I use .1? Technically, yeah, because I'm coming straight from the internet, and they see this as a new entity. But I never mind that. To keep it simple, we just gonna put 2. There'll be a different network. So when I do different networks like this, 192.168.2.14.12, everybody's segmented off in their own little division, right? But they could be logically all in 2 rooms in this admin building in an old school library. They could be all within that one sector, that one real big room with all the books, right? But in a logical form, this is what, when you get your job, you'll be sitting in like a meeting, and this is how we'll have this up on the whiteboard, and we'll say, hey, we need to put antivirus where. Well, let me jump back. I'm jumping. Okay. So this is how it looks logically. Now we got everything talking to each other properly in its own right. But do you think that the admin building would need access to the library? Thumbs up if you think so. And if you don't think so, well, thumbs up if you think so. So if you don't think so, somebody tell me why we don't want the admin building having access to the library. And it's just resources, right? Maybe they want a print in that building. So Jonah says yes. And it's I'm sorry, go ahead.
The admin should have access to the library.
I'm sorry, you cutting out just a little bit. Say that one more time.
I said the admin should have access to the library.
Okay. I would say it's a case by case scenario. Maybe. But if we do that, right? So let's duplicate that. If we do that, the only thing we need to do is take their router and route it in to their router. Let's make that a different color. Let's make that a red. That's not what I want. So that's the only thing we need to do in order for them to talk to each other. And the print, like if you got your teachers over here in the admin building, but then they wanted to print over there at the library, just in case the printer went down, then yeah, we can give them access over there like that. So I would say, yeah, that works, right? But then I would be, if I'm on some stuff that day and I don't feel like being fooled up with it, I'm gonna be like, nah, we'll just get you another printer here in the building. You can walk over to the library and print. Because remember, by just adding this one line, that attack vector just got that bigger, right? The footprint was like this. I'm gonna delete it. The footprint was like that, separated down the middle. But now, since we're gonna connect the two, I can come in here and not only create havoc here, but it essentially can travel up and then over. So if I'm thinking from a security standpoint, if I'm fighting a virus that's just is jumping networks like that, then not only do I have to worry about the admin building being protected, I got to remember, oh snap, man, we put that line in to put the doggone library over there too. So not only do I got 200 PCs over here I got to look at, I got to make sure that these 200 PCs is to look at, as well as all the other resources. So it's really up to you as a professional to understand, not understand, but like, what does the business call for? And that's really on you. I mean, if you want to do it, more power to you. It'll be easy. It'll be convenient. Your users will love you. But I probably ain't gonna do it. I'm probably not gonna do that. That's gonna be a headache. And that's not to come to your way, but that's the real world. That's a headache. But no real wrong or right answer on that. Now, going back to our slides, so we have this connected. We're gonna go with that. Anybody want to tell me what's the single point of failure? If a bad storm was to come by and this turns black, can I turn it black? No, I can't even turn it black. Dang. But this cloud turns black, and now we don't have any internet connection. That is the single point of failure. Also, we don't have a firewall in here. So just so I made sure that I made myself clear on that. The single point of failure is the internet connection itself, the internet provider. If the internet provider cuts a fiber line near the school, then now none of these buildings have internet access. What we would like to have is another internet provider off here and have a secondary connection here, and maybe over here as well. But not saying that we should have two separate like Time Warner and then Dish over here. But what I'm saying is that if we have this is with Verizon and they're giving us internet, then maybe we want to go with Time Warner, but over here is our secondary, and we have that as a fail open type of concept. So if something happens to Verizon, then we still have minimum connection stuff that we need to tell the students, hey, don't come in today. Make sure you go to online classes or what have you, whatever we need to do. But we're not just left out there, not telling them what to do. Firewalls. So let me get my firewall. So very easy. Where is my firewall going to go in this case? Your firewall, I have, like, remember, we have two different firewalls. We have ones that's sitting on our, let me get this out of here, sitting on our desktops, and we got some sitting on our network. So our network firewall is probably going to sit right up in here. Remember, this is a, let me change this color. Blue. This is a firewall. I thought I duplicated it. And it's going to sit right there on the router. If not, the router may have capabilities to do that. It's according to what kind of router you get. But 9 times out of 10, you want that that firewall to sit at the edge of your network. This is what when they say the edge, this is what they mean. From the internet provider into that first router that you have. Right? So we want to have the firewall sitting right there. Then we want to have firewalls sitting on our endpoints. These won't get it, but you can put one up here. Here. And that's across all three. Well, for all three of them needed. Now, just in case something comes from the outside network to the internet provider and comes into your network, and it just so happens to get past this first firewall and goes to the second landing point, which is the servers, hopefully this firewall can catch it and do away with it. Okay. I did not mean to spend that much time on this, but I hope that everybody got that. Any questions on this topology section? All right, so I did that. Wanted to show the PowerPoint. So we talked about the layer 7 type of application firewall, and I said that these applications, they are getting updates, just like regular computers are, and I wanted to show that to you so you can have an idea of how that looks. So if you go down to account, you can see how Microsoft Office 365 can receive updates. These are things that's coming past the firewall into a particular application. This application doesn't get updated by doing the control panel and then a update all system through Microsoft. It may update on its own. That's the wrong spot I was trying to go to. It may update on its own. So sorry. Gotta go back here. So Microsoft 365 will not be updated within here, which you would think it probably would because it's part of Microsoft, and you would think Microsoft would see its own products. But this is where that layer 7 application firewall comes into play at. It'll look at the traffic going directly to the application and seeing if that's malicious or not. And then finally, I wanted to finish off with remote desktop. So I got my server up and running. And this is what I tried to show you guys last week, but I did not have my controls hooked up. But what this does, this virtual machine is a good way, like I said, to put it on your machine and practice different settings, messing with it. It's just like having a new computer on your old computer. So what I wanted to show you was the remote desktop feature. But while I'm waiting for that to boot up, I'm gonna show you the the Active Directory piece that I wanted to show you guys last week. I'm gonna let that boot up. But then while that's doing its thing, I'm gonna close this out. And here's another pro tip. If you are lacking experience with servers, it's real good if you can go in and find you a ISO with VirtualBox, upload that ISO, and start just tinkering around with the server. And that way you can update that resume to show that you have that server experience. Just to be able to go through and do this part, configure a local server, see what roles and features you can add, and create some groups. Very easy to do this stuff. Well, it's easy to do this when you're not worried about breaking your own machine. Okay. So it's definitely, something that you can do on your own. So whenever you get in the real world, you're able to do this with no problem. So this is what I wanted to show you guys when it came to users and groups. These are the security groups that I was talking about putting them in certain groups to having certain permissions. Active Directory is pretty much, this is all it is right here. And the only thing you're doing is you're going in and you may change passwords here, by right-clicking and resetting the password. Reset that password, contacting that user, telling them to go ahead and do the password that you set up and have them reconfigure it. But you can also put them in certain groups here and be able to assign them to certain groups, such as the finance group that has only permissions to that finance that finance logical domain. Okay. So, but this won't be the last time when I bring up Active Directory. That's for sure. But the last thing I wanted to show you guys is that um, remote desktop. So I'm gonna minimize this and put this off to the side. Remember this window right here. This is a remote desktop application that I got as an endpoint, and it sees two computers that it can remote into. Remote desktop is just pretty much just remoting into another PC using port 3389. I know that I'm pretty sure that that's the port number, and you're going to pretty much open up a window that looks directly like the user's PC or whatever they're using at that particular time. So you should shortly see another window that opens for me, and it's going to have a duplicate window over here. And what that means is that I'm remoting through the internet to this virtual machine, not my machine that's out here in the background with the desktop on it. This with this the tree desktop. This is not that PC. This is that virtual machine that I spun up. So now, as you can see, I'm moving my mouse in one spot, but you can see that mouse moving as the user in that other spot. So in the real world, if even if we're across the nation or across the world, once I remote into it, your machine, it's pretty much I'm controlling it in real time. And I can just pretty much do whatever I need to do. Um, and it's seamless, very seamless. I love this feature. When it comes to the real world, though, you need to get permission before you actually provide services like this. Um, but for a lot of you that come into this field, this is one of the applications that you're going to be working with. Even for Mac users, you should be able to get remote desktop as a added application on and be able to remote into Windows PCs, no problem. But that's pretty much it. That's using port 3389, remote desktop. Any questions? All
Did you
right.
use a different remote desktop application or the one that came with Windows?
I used a application, the one that comes with Windows. I did not use that one because it's going to take some configuration, and more than likely you're going to need to be on the same network to actually get into that PC that you're trying to remote into. So you could set one up in Azure, right? Cloud platform, and you can use remote desktop connection to it, which is that comes with Windows, but it needs to have permissions on that network in order to allow you into it. Because essentially, once you log into another PC, you got whatever permissions you have is it could be like a full admin. And so you can bring things over from your PC onto that new PC and drop viruses off from a security standpoint. You could take files off. You can also um, like with this application that I got here, I could do this. So you see this other icon here. This is a file transfer icon. So let's say if I didn't want the remote to remote into the PC, I can still transfer files to its folders without the user having any kind of idea of what I'm putting on there. I can take files from it. I can put files on. this could be very helpful, but it can be malicious at the same time. And that person can still be working on their machine and not really know what's going on. Now, in this case, it does give a notification that Lee has started a session with your PC, but you don't see any type of change to the desktop. This person could still open up any type of application and still do their work. Okay.
Yeah.
Shut that down. But yeah, if you guys can get your hands on a ISO, if you want me to find you one and put it in Cyber Up, I could do that and get you give you the link to VirtualBox. VirtualBox looks like this, and you could spin up a virtual machine anytime you feel like it. If you have the memory as well as the capacity in your hard drive to do so. This is VirtualBox. So see right here, I got a Windows 10 machine that I got.
So what's like the memory of the laptop?
I would suggest 8 or 12. I would really want to push for 12 because what I've just did, like everything that I'm doing should be lagging. My computer should be lagging if I had 8 gigs of RAM because it takes up so much resources just to do a Zoom. And since I was able to do a Zoom with y'all and it be seamless, and I had a storm outside, and I spun up a virtual machine, and I was on Canva, I think that's pretty good. And my virtual machine stuck. So I think that's pretty good. And it learns, not learns, it just has enough capacity to do all of those things. And I use remote desktop to remote desktop in to itself. So it just gives you more, it gives you more things to that actually can be done all at one time. On a lesser computer that has less memory, you probably need to shut down some windows or some processes to make sure that you can do those type of things.
Some time ago, I spun up like about 4 virtual machines because of something I was doing one time, and my laptop slowed to a crawl. I almost couldn't do any other thing on it.
Yeah, Chrome could be a resource killer, but I love it. And I only do this on this PC. My other PCs, I don't really do it on because I got this one from Walmart. This thing is, I got this from Walmart, and it was just kind of like it was a $500 gateway, but it had the RAM that I needed. So I was like, man, I'm getting it, and I'll just do my teaching on it. Everything else, I got like 4 gigs, 8 gigs, just because it's more efficient. I mean, more cost efficient. That's just the nature of the beast. The more you get on the RAM or the hard drive, the more you just gonna pay.